Okay, we're going to look at asymptotes in this video. So first of all, to look at a rational equation, we have a polynomial to the degree n and a polynomial to the degree of m. And we want to know when m is greater than n, y is the asymptote, y equals 0. So that's the question we're trying to answer. Okay, so let's look at this equation. So in this case, my n is equal to 2 because it refers to the degree, and my m is equal to 3. So m is definitely bigger than n, and we want to know why the asymptote is 0. First of all, you have to understand about an asymptote. An asymptote is looking at what's happening to y as x is heading to infinity and to negative infinity. I'm just going to focus on infinity for this example to make it short and brief. So I picked some ordered pairs, and so this is heading towards infinity because it's getting bigger and bigger. And I'm going to substitute in the numbers. So if I do 1, that's going to be 1 squared plus 3, which equals 4. And then I'm going to do 3 times 1 to the third power plus 4. Well, 3 times 1 to the third power is 3 times 1, which is 3, plus 4 is 7. And if I take out my calculator and do 4 divided by 7, I get 0.6. Now I will do the same thing with 5. So 5 squared would be 25, plus 3 is 28. And down here, 5 to the third power is 125, times 3 is 375, plus 4 is 379. Again, I already did this. I took out my calculator, did 28 divided by 379, and I got 0.07. Then I did the same thing with 10. 10 squared is 100, plus 3 is 103. Then I did 10 to the third power, which is 1,000, times 3 is 3,000, plus 4 is 3,004. Took out my calculator and divided, and I got 0.03. So if you notice, my numbers are getting smaller and smaller. They're getting closer to 0. So as x is heading to infinity, y is heading towards 0. So my asymptote would be y equals 0. Let's look at it from a different approach. Let's pretend we didn't have the full equation. Let's just look at laws of exponents. In this case, if I have x squared divided by x cubed, that is x to the negative 1, or 1 over x to the first power. Let's say, because we work in a world of base 10, we have 10 fingers, let's look at the number 10 to the negative 1. Well, 10 to the negative 1 is 0.10, because it's 1 over 10, 1/10. If we did 100, it'd be 1/100th, and so forth. So we notice that because of this exponent, as this number gets bigger, so I substitute in different numbers, it's actually, the equation itself is going to get smaller and smaller. Because if I plugged in 100, like I said, 100 to the negative 1 would be 1 over 100, which is 100. And then 1,000. So as I keep substituting in, it's going to get closer and closer to 0. Because when we did the laws of exponents, you notice nothing ever really gets to 0. It never equals 0. Another final way to look at it is, let's go back to the basics. Let's go to fractions. If I have the fraction 1/2, then I go to 1/3, then I go to 1/4. Well, this is 0.5, this is 0.33, this is 0.25. It's getting smaller and smaller. So if I had, 1 over 32, 1/32 of a slice of pie, that's almost 0 in a kid's mind because that's a really small sliver of pie. So that is why the asymptote, horizontal asymptote, for an equation in the form, let's look at this form, where we have a polynomial divided by a polynomial, and my exponent is less in the numerator than it is for the denominator, because that bigger exponent means you're going to multiply this an extra time. So it's going to make this number on the bottom bigger and bigger. So your top is a part out of the whole, and the whole's getting bigger, but your top's not getting as big as quickly, so it's getting closer and closer to 0. The concept is, when you're looking at asymptotes, what is happening to y when x is heading to infinity? So as x is getting bigger and bigger, what is happening to y?